Hello guys, I'm Nischay. Welcome to Chai Time with Data Science. So today Sanyam is not there, so I will be hosting.
Hello guys,
Oh,
I'm
I
Nish.
guess okay. Yeah, so I think we should get forward without Sanyam today. I hope you all don't mind. Yeah, so basically this is my profile. As most of you might not know me, I'm not as famous as Sanyam. So yeah, this is me. I guess
I
I
go for
couldn't
I
bear
go
it more. So
for I go
Sanyam,
to
you should
grab
join.
chai for one day, and you take over my channel. That's-
I think I should.
so today I'm late to grab my chai, and I asked you to kick it off, and you all of a sudden take over the channel, which is nice. You can go for it. People are already here. Hey Vadim. Hey everyone. Thanks for joining. This is a planned joke which didn't feel very natural. If you can tell, that's quite obvious. Uh, Nischay is India's, I think, best and also worldwide one of the best competitors on Kaggle. On Kaggle, as you can see, he's ranked 18. He's just become a 3x master. Although he wasn't for 110, then he's again now. That's another story. Um, I asked him to join me today because he's competed in both the feedback competitions, and I wanted to invite him to help us understand the solutions as well. So the good learnings today will come from Nishchay's sharing. Nishay, thanks so much again for joining me.
Thanks for welcoming me with such a warm welcome. And yeah, I'm very excited to see most of the solutions. Like most of them I have already read, but there are few which I missed. So I'm excited.
That's awesome. Maybe you can start with your solution. So things that you want to share. I know you joined very late in this competition, so maybe you can
Yeah, I
start there.
did.
How did you approach and how did you go about this?
Yeah, so I actually started pretty late in this competition, like only 2 weeks before. So that was much more challenging task for me to compete solo. So I was like, yeah, I have already participated in the last feedback competition, which was the first version. So I thought that I was little overconfident, like I might do well even in the last 2 weeks. But yeah, it didn't go as planned. So I started off 2 weeks earlier. Then I basically simply tried to replicate my previous competition solution. So I started off directly with a token classification, which was quite famous during the end.
Mhm.
So at the end, it was more like I was stuck with a single model, and I didn't have many models for ensemble, which is quite a necessity if you are participating on Kaggle, that you should be having a multiple models ensemble so that you could climb up the leaderboard. But yeah, it didn't went as planned. I was stuck for quite a few days, stuck with the pseudo labeling part and all that. So yeah,
Okay.
but yet I would say it was quite fun to participate, and I'm looking forward to participate again in the third version of feedback, which should be coming soon, as the host says.
You did finish quite high though. You were 22nd, so that's that's much higher than I don't know 1,500 other people at least.
I guess I'm quite used to the being in the 20s at the end of private leaderboard.
Maybe we can now start with just setting up the context for the competition. So this was the second run of the feedback competition, and in this one, the goal is to classify argumentative elements as effective, adequate, or ineffective. So you get passages from students in the 6th to 12th grade, and you have to tell if the arguments that they have provided are effective, adequate, or ineffective. We've already gone through the earlier feedback competition, and this is quite similar to that in many ways. So if I go to the training tab, as you can see, so you have all of these discourse text where I didn't see any funny discussions this time, but last time I managed to find one where like a student had written, oh, this is so boring, mic drop, tinkle tinkle little star, all those things. Maybe not this time. So you have these discourses, and it could be a lead, a position, a claim, evidence, so on and so forth. And then you have to predict if it's adequate, ineffective, or I forget what's the third column. I think ineffective. So based on that, you're required to predict all this. I also pulled up. I can pull up an ETA notebook to show a few things. Leonie is an absolutely awesome expert at EDA, so we can trust her skills here. I'll pre-upload before reading because I know this would be good. And Nisha, please feel free to interrupt me anywhere you think I missed something.
Sure.
Um, so as I mentioned, you have all of these discourse texts with the type and effectiveness, and you're required to predict if it's adequate, ineffective, or effective. And as it most things in life, things were mostly just adequate here. So most of the labels uh, are adequate. There are some effective and some ineffective. And here's the distribution of the types. As you can see, claim and evidence are the most in numbers, in counts. And you have all of these essays with the discourse types, and you're required to predict the effectiveness. Um, I did go through this notebook, but I think that is a good level highlight. Anything you want to mention here, Nischay?
No, I think that's it. I could just differentiate between the last feedback and this feedback. So basically, like in this feedback, we had to predict discourse effectiveness, which is another new type of label which we were presented in this competition. Meanwhile, in the previous competitions, we have to basically segment the discourse types, which type of discourse is present in a particular text. So that was more of a segmentation task, whereas this one was mainly a multi-class classification. So that was the most generic difference.
That makes sense. So, just because it's classification and that's supported quite well in Hydrogen Torch, which so disclaimer, Nischay and I both of us work at H2O.ai, but we think it's quite an awesome software. So let me pull that up. Hydrogen Torch is an AutoML product for deep learning created by the best people like Philip Singer, Yawin Babakin, and the likes. So what I'm trying to do here is find the correct tab as I stumble. I just did. Now I can share my screen. Let's see if that works. So I thought maybe this can be a good baseline because this comes from absolute legends. And I ran a few experiments here. So what I've done here is this is the UI of the product. And I've already imported the data set. So if I were to do this again, I would just enter my Kaggle API, which I pre-did. And I've downloaded the feedback price data set here. I've set it up as a text classification problem. You can see all of the data here. You can see the stats here. So you can see that there are 36,000 examples. There's SAID, text ID, text type, and effectiveness. And then what I did was I decided to run an experiment. Maybe Nishte, you can suggest the hyperparameters
Parameters.
and different options.
Okay.
Yeah, sure.
I hope the model doesn't overfit in the first epoch itself.
So this zero folds.
Sure. Maybe you could
Um,
change the validation strategy because there could be some kind of leakage if you use simple K4. Maybe you should use group K4
okay,
and group based on the SIDs,
sure, that
because
makes
if
sense.
you would use same SID in many different folds, then it might cause some sort of leakage.
Mhm. Um, that makes sense. Just one fold is fine because we don't want this to run. Although it usually takes like 10 minutes to run an experiment.
Label column should be discourse effectiveness.
Mhm. Discourse text, that's right. Max length, as we saw, is 256 is about ideal. In Leonie's notebook, they had written. I don't think I mentioned that, but in their ADA, they suggested that 256 is an ideal length. What backbone do you want to try?
Anyone which might finish earlier, because
Uh,
this was quite more of a computation competition. So if you would be training a large model, it would take at least 2 3 streams of yours.
okay, Roberta Large, point on dropout. Do you want to change the pooling strategy or
Mm, I think it's up to you, but CLS token is fine.
okay? Uh, Maybe a
Loss
few
should.
warm up epochs. I think this is good enough. I'll just change the metric to log loss since it's a classification problem, and I can run an experiment now. So what hydrogen torch is going to do now is it's going to try all these settings and come up with a few models. So I just wanted to use this as a baseline. I've already done that, so I'll go over there and just share the learnings from here. So as you can see, this got to about I don't know. I don't think we can like use this directly, but I just wanted to use the summary from here to see how helpful this was. So this can also give us a few ideas for the model, and as a baseline, you already know how well is this performing. So as you can see, for the loss was about 0.022 for this example and 0.0056 for this example. Here are a few examples, and if I head over to logs, I can see what all experiments were run here. So overall, I can see that here are the best validation examples and worst validation examples. And here are the metrics that the model had come up with. So the best F1 score was 0.74, best log loss was 0.85, which would you say is a good baseline? So would you sub with this?
Yes, I think it is, like, given we didn't tune it much, right? So I think it's good to start with.
Okay, that makes sense. So maybe let's see if we see any Roberta based models in the write-ups. But I just try to use this as a baseline to see. Vignesh also wanted to run Roberta, so I'm glad I didn't see the comment, but still manage the same setting. What I'm going to do now, and by the reason we do this live stream, is so we spend the first few minutes to set up the context, and then we start going through the top solution. So that's what we'll do right now, and we'll try to understand the top solutions. Um, Here we go. I always struggle with finding the right screen, but that's okay. Everyone knows that by now. Um, Another thing I wanted to point out that made us quite happy was my colleagues from H2O.ai were on the first, third, fourth. So they were parts of teams, of course, but we saw many people from H2 in the top ranks. Nischay was just outside gold as he was complaining. But there's always an internal celebration that happens whenever anyone ranks so high in a competition. Um, so maybe we can start with the first position solution. So they say the solution is based on a two-stage ensembling, multiple transformer-based model with different techniques and adding second-level models on top. And they also employ multiple rounds of pseudo tagging and pseudo labeling. Um, so pseudo tagging here would mean taking the older competitions data and putting tags on it, right?
I think so. I haven't heard of this term before, pseudo tagging. I
Okay.
think they might have explained it a bit in the later of the solution part. I'm not sure.
Okay. Um, and for CV, they mentioned they had a near perfect correlation, and they've also plotted it. So as you can see that it's quite well correlated for these guys. And they say as the data is small to medium size, the metric is log loss. The scores can vary, and this is typical for deep learning models. Given the model training was quite fast, they relied on only checking blends of 3 seeds for each models, and single model scores did not correlate well here with their ability to blend into larger ensembles. So a better individual model could have quite a worse performance in the blend. Diversity really mattered here. So I think what they're trying to say is, as they found combining different models really helped them get the boost. Was your solution a blend as well of
I
different
think it was
approaches?
a blend of three Deberta V3 large models only. But as I missed on the part of the diversity, that is why I think I didn't get much boost as the top scoring teams. Also, my single model wasn't that good enough.
So by diversity, is are you like referring to changing some tokenization? Generally, is it like different tokenization approaches or
There could be many
augmentation?
things. Like in this competition itself, people generally use two types of pipeline. But one which is based on sequences, which is like training your model on every discourse sample, while the other one was the tokenization approach. So one the major diversity part could come from these two approaches itself. Like if you train a model on two different approaches, then you could say that these models are quite diverse to each other, so that might lead to much better ensemble score. So also, like if you are dealing with a same type of strategy, maybe you could change head a little bit, like maybe use an additional sequential head like LSTM or RNN. So that might also lead to diversity in few cases. Yeah,
That makes
so
sense.
my main what I did was like in one five-fold model, I simply added a LSTM layer, because of which that got quite less correlated with the actual model. Also, I preferred using second stage. So for few models, second stage were working pretty well for me. So in those models, I use second stage model as well, while for some models I just use the single stage model. So that also led to some sort of diversity.
That makes sense. So let's continue reading the first position one. So they say for modeling, it's a combination of different modeling approaches, which I think which is where the diversity is coming from. Part of it, at least. Uh, Most of them are based on idea of training on all discourses from single essay at the same time. This not only made training and inference much faster, but also improved accuracy. So in the
Right.
following, they describe the approaches in more detail, and they say they could only get V3 large to work. I don't know who. Maybe someone tried V2 XL, but V3L still seems to be the king of all Deberta models. I think. Um,
I
so
tried
they
V2
say
Excel one, but that model is like too large to converge most of the time. So that is one of our downside of that model. Like it's really hard to converge that.
it also times out a lot, right? Most of the time.
Right. Yeah, it might take around 4x times compared to a large model during inference.
And as a reminder, if you're new here, the timeout here means to. So usually you have code requirements where you need to complete your inference under 9 hours on Kaggle. So if you train a very large model, it will time out. And this competition also had a special efficiency track, which meant how fast can your submission complete and how higher can it score. That's we'll also cover that later. So they say the main idea is to feed a full essay into the model and then pool each discourse separately and then feed it to the final layer for prediction. The main approach here is similar to what others shared, but there are some differences. So they furthermore share how their input varies a bit.
Right.
I'll just let everyone read this if it makes sense. So they say one sample includes one essay, and they start by adding a list of all types of discourses in the essay with a separator token, and then they mark individual discourse with start and end tokens. And then they run this through the backbone and pool between start and end tokens for all discourse types. So this, since it's just one essay and it's just being passed to the backbone once, it makes the batch size equal to one. And as you might imagine, that also depends on the number of discourses within the essay. Um, I think this is quite self-explanatory. Do you want to add anything here?
No, I don't think so.
Vadim says you can check out our solution and see how much we gain from model diversity. I'll get there, Vadim. Thanks for pointing that out. Also, congrats to you on the I think 88th position finish.
Yeah, I think he just become one of the youngest competition expert. Apart
Vadim
from the
keeps
fact
achieving
that
many
he's
things.
already a grandmaster.
Yeah. Uh, so they say in another approach, in another example, they do not specifically add the type to each discourse, but they use an auxiliary loss to predict the type of each one. So this
Yeah.
regularizes the model a bit and allowed for longer training. Another approach does not have the auxiliary loss and trains the model based on this approach. So where they're using separator tokens followed by start lead, and then they mark the end of the lead and the start of the positional argument and the end of the position. I think this is also where the diversity is coming from using these different
Right.
approaches.
Hmm. Like this is one of the thing. Like if I remember correctly, Nicholas from Hugging Face was the one who suggested this idea of token wise classification. So basically, since then most of the teams started using this approach. So I think one of the main thing was to how well you could use those tokens in a token wise classification model, because like the task was to predict for each discourse, right? So that was one of the, like in debata model there is one thing, like it doesn't read well about which tokens we are using. So it has a relative positional encoding, so because of which, like it was also challenging to like tell the model when we are exactly using, when we are exactly getting into the next sequence or next sample. So that was also a task. So many teams used starting or ending index tokens. They maybe add an additional tokens in the tokenizer of debata. Also, I liked the approach of Abhishek Thakur, in which, if I remember correctly, he changed an entire pipeline of the Debata V3 large model itself. Like he added another, just like we use token type IDs embeddings in the Debata model, he added additional embedding layer, which was of discourse type embedding layer. So in that embedding layer, he was just token simply passing the discourse type. So it was basically trying to tell the model like, yes, we are now changing the sample or the sequence, so you might start focusing on the next discourse itself.
I think they've open sourced this approach here as well, uh,
Right.
and it's a part of their uh, deep learning, awesome deep learning framework that we also use as a baseline for our AI for code solution. So I'll drop this
Right.
link in the chat.
I also want to add something, like I used Tej in the last feedback competition, so my complete solution was based on his library Tej. So it's an awesome library to work with.
Again, the link is there in the YouTube chat if anyone wants to find that open source code. Um, so coming back to this, for this approach, they again first we're mixing a lot of things, but we're coming back to what we were reading. So for the first position approach, they say about they now they're talking about how they classify the tokens. The chunks of the essays are treated as separate tokens. Individual chunks either get the efficiency label or O label as if they are outside the annotated essay. So it's either adequate, inadequate, or O. And subsequent process is similar to the idea above. They pass the whole essay through the backbone and then they apply local average poolings for each chunk, followed by a dense classification layer on top. I think that is quite self-explanatory as well. Yahoo always writes really nice posts, so it's, you don't have to spend a lot of time sifting through them. Then they say, I find this quite interesting. They use bag of words light GBM model, which I wouldn't have expected in a winning solution. Um, okay, I think coming further, they talk about hyperparameter tuning and regularization. They spend significant efforts on tuning and regularization techniques, and they say augmentations weren't really helpful for NLP fine tuning. Only mask augmentations work quite well. And they say hyper parameter tuning was quite important, which I think is true for all NLP models, right? where like you change it by one decimal place and the model stops converging.
Right, that is true.
Um, Next, they talk about second level models and ensembling. So the log loss metric is always only optimal if the mean predictions per column match the mean predictions of target column. So they're just defining how log loss works. And then different models do not always reflect this mean very well, which is why they say they add an additional optimization after each model to adjust the train mean.
Hmm. Makes sense.
For for ensembling different models, they resorted to directly optimizing the blended weights. And they say we had several models with negative weights. I'm curious, do you know what techniques are used for blending weights, or is it just trial and error as well here?
What I usually prefer is you could simply use Optuna. So, like
Mhm.
Optuna is generally used for hyperparameter tuning, but it is quite famous on Kaggle. Like you could also use Optuna for adjusting the weights of ensemble. So, I think I have also published a notebook on Optuna itself. If I'm not sure, maybe I have to recheck that. So, like basically the idea is you first generate the oofs of every model and then use those oofs to adjust the weights. Like if you would take a simple mean, then the weights would be simply one upon the number of models you are using. So similarly, Optuna works with a strategy like running it kind of a brute force technique in which like you could maximize the CV using Optuna.
So you say you're using out of fold predictions, and based on that, you're
Right.
optimizing the weights with Optuna, right?
Correct.
Okay,
Hmm.
that makes sense. Uh, Vadim, who I don't know where his knowledge comes from, he seems to know many things, also pointed out other techniques that can help here. Thanks, Vadim.
Right.
Coming back to light GPMs, so they say for the second, I'm using a mouse, so my scroll is inverted. So sorry, everyone. I'll use my trackpad. For second level light GPM models, they took weighted ensemble prediction together with individual model predictions and generated feature based on the whole essay. So
Okay.
they talk about neural networks that they tuned here. The first takes the weighted ensemble prediction as well as an average across the essay and across the type within an essay. And it's just a 3 layer neural network because this is a second stage model. And the second one takes the same features but on an individual model basis and then uses a con 1D layer. And as you can see, this is a third position boost, but that's quite essential when you're trying to get on the top of the leaderboard. Um, Next, they talk about three stages of pseudo labeling. So, first, they train an ensemble of models only on trained data, run predictions on the previous feedback, and then use soft pseudo labels by concatenating pseudo labels with actual labels, and then pre trained models on pseudo labels and fine tune it. Then they repeat this a few times to get an ensemble of models trained on this. I think this was quite a straightforward solution. Things that stood out was they, to me at least, and I'll ask Nischay in a second, that they changed the inputs quite a bit. They fine tuned and really pointed the model towards where things are starting, how are they ending. And there, furthermore, they had different ideas, as you can see. After that, a few more things that I think when you read them are quite obvious, but maybe after you have the predictions from the model, you can try these approaches on a second stage ensemble. Anything else that stands out to you?
Yeah, I think that's good. One thing I really liked about their solution was how they used like discourse types at the beginning itself.
Mhm.
So that is one of the thing like which I also missed because like if you would see the length of essays were quite diverse, like ranging from 700 something to even in 4,000. So it is quite a possibility that you could miss some of the samples during the training, because you have to use a fixed max length, right? So the way how they used at their discourse types at the beginning itself, just to define the model, like, yes, these are the particular discourse types which we are using. So I think that might have worked pretty well for them.
That makes sense. Okay. Uh, should we cover the efficiency? Do you want to cover this?
I think we could, but if I read correctly, the solution is quite the same. But yeah, I think Philip come up with a way to like get a great score with a single model itself. So it's worth reading, I would say.
Okay. Do you want to read this time?
Sure. Yeah, so in the summary itself, they like, so in this competition there were two tracks for the prize. One was the how well your mod and some like how well your approach is based on the log low score, while the other one was the efficiency track, in which like the most efficient solution works wins. So in that case, this just simply used a single debugger wheel 3 large model, which scored around 0.557 in the private leaderboard within 5 minutes, which is quite impressive, I would say, because usually, if you would also see in the description itself, the time limit was of 9 hours, right? Because the hosts also expect that the solutions would be at least in hours, but they come up with a solution within which would inference within the 6 minutes is quite impressive. So coming on to the model design, if I'm not wrong, they use pseudo labels. So yeah, he mentioned like they generated pseudo labels of the previous feedback competition using their ensemble solution. So basically, they are trying to integrate some learning from the ensemble of their solution to a single model itself. So for that, they generated the pseudo labels and used those pseudo labels along with the actual training data to train that V3 large model. So I think that was their idea. Apart from that, they also added the second level models, because in second level models, if you would see, we are simply using machine learning based models or a three-layer neural network, as Sanyam mentioned earlier. So those models are pretty fast, if you would see, because we are just simply passing the predictions as a feature. So it shouldn't take much time to do the inference. That might be in like 20 or 30 seconds, the inference for that second level models. So I think they use that as well in their efficient solution. I think this that is enough. What else I missed? Yeah,
I
also
think
there is one thing called dynamic padding. That is quite famous on Kaggle these days. Like basically it is used in your data loader. So like during the tokenization, either you do some sort of padding or truncation, as we were using token level solution. So we can't actually truncate the essay, right? Because it might be possible that we missed few of the samples. So that would lead to an error during the submission. So to overcome that, there is one thing called dynamic padding, in which like if you are using data loader, and each batch would be like based on the highest max length of that particular batch. Like if you are using a batch size of 4, and the sample with the maximum length is around 1600, while the other ones are like 400, 800. So if you wouldn't use dynamic padding and use a fixed max length, which might be 2048 or something, then it would pad all the batch samples to 2048. So that would take more time compared to if you would use the dynamic padding and use it to just run dynamic padding. What it actually does is, I think it would pad the samples based on the max length of your highest length sample. Like if it was 1600, then it would just pad until 1600 only.
that makes sense. Thanks for explaining that. Again, they've also open sourced their submission, so if you read this, you can find the link here. I'm not going to paste the link because it's a large link. You can just search for it and find it very easily. Uh, I think I'll. So the second place is quite convoluted. So I'll cover the third position one first. And Tushant, who's already been on the podcast as well, is also from H2O. So it's I know I can get through solution quite fast because I've already interviewed him. Um, so I'll cover this one. And they've already added the detailed one, but I'll go through the shorter one first. So they say things that worked well for them, and I'm sure they tried many things. So usually people try 50,000 things in a competition, and five of them work. That gets them into a gold medal. The difference is many people just try 100 things, and people on top try 50,000 things. So things that worked from them are span classification with LSTM head and multi-head attention, span mask language modeling, uh, data augmentation uses using T5 model. This I've not read before, so I'm not sure what this is. Um, then they are
I think
using
they explained it in the solution later on.
okay. I prematurely said I don't know this. Uh, they used token mask augmentation, adversarial training, and multi-sample dropout. I assume this is for regularization.
Right.
Do you know what prompt-based learning is?
I never used it, but I think it's similar to the question answering task. Like you basically give model a prompt, and based on that, it actually gives the result on the context which you are using as text.
That makes sense. Okay, let's go to the complete solution link. So I'll probably mention their architecture first. As you can see, they're feeding the essays into the transformer model, and from the output, they feed this into a by LSTM layer followed by a pooling layer where they're predicting the spans, as I understand correctly. And
Right.
finally, this goes through a classification head that gives out the logics. Is that a good overview?
Yeah, that is it. Like they applied multi-head attention on this pen tokens. That is what I read.
So now reading through order, they pre-processed each essay into newly added span start and span end tokens. To provide
Mhm.
more context, they added a topic segment like so, and they inserted, as a minor detail, they also inserted tokens to indicate essay start and end. I think this is becoming more of an approach lately with competition, right? Where you like specifically point your transformers to different spans.
Correct.
Next, they talk about span mass language modeling. They say to train newly added tokens and adapting to specific task domain. They continued the pre-training phase of the backbone with mass language modeling, and they found a big boost with these augmentations. So changing masking probability to a very high one, and they also have linked a paper that suggests this. So usually it's 15%. I've seen solutions that had lesser than this also. And then they say masking continuous tokens of 3 to 15 instead regular random masking. So masking may be like a longer set of words.
Mhm.
It's again the small tricks that really help understand these things. Uh, and then they say changing max length to 720 to match average essay length in fine tuning. Next, we come to the mysterious T5 augmentations. So they say since they couldn't find external data sources, they explored way of creating their own, and they had a few label preserving augmentations. So they used the 2022 label data to generate synthetic examples which are directly added to train during fine tuning. So for that, they use the T5 large model with a sequence to sequence text. So this is quite similar to back translation in a way, I think, where you
Right.
not quite, but you're using a language model to generate more examples, and you're using that as train. I don't know how would you put this, but it's quite an interesting way to do it.
Yeah, you could. say that.
Um, and they say the model was pretty amazing. They couldn't distinguish between which one came from where. And they say Heng had previously shared this somewhere as well. Finally, they talk about fine tuning, which I think is quite straightforward. So I'll skip past this, and then they talk about different backbones. The only one I hadn't heard of here was Luke. So you can check that out if you want. But this is the first time I saw this model.
I think it is something like entity aware self attention model, which is based on Robota itself, but like its embedding layer is quite different compared to Dbata or Robota and all. So it is usually built for tasks like NER itself or any relation classification type of task. So
That makes
it's
sense.
a new model, if I'm not wrong.
Um, let's see if I can find this. So this definitely would bring something else up. Gospel of Luke. No, I don't want that. Page. Deep contextualized entity representation with entity self-aware self-attention, as if those words made any sense. uh, but no, again, you can find this here. It's already there in the model hub as well, as I understand. um, so you already explained how meta models work. They mentioned the same thing, which is they take two meta models based on out of fold probabilities and additional features. The LSTM based ones just had stage one model probabilities, and they said this had better correlation. LGB ones had stage one plus additional features, count of next line per essay, count of discourse ID per essay, and pause tags. So POS tags are adjectives, verbs, so on and so forth, where you literally label what a word is referring to. And many a times these simple features also provide a really good improvement to which I always find counterintuitive. Like on the one hand you have these like crazy transformer models that you are fine tuning so much, and then you literally pass number of new lines per essay, and that gives you a boost. But it does for some reason. So
They
that's
actually
where the
did it
science.
for me as well.
Okay. That's I'm sure many people
It's
converge on
more
similar
crazier
approaches.
that you might not have imagined in the stacking part. So, and they actually did work pretty well because I don't exactly know why they work well, but like if you would add some additional features along with the predictions, then these meta ML models could work pretty well. Like I could also share my code if you also want that too.
Please.
Okay. Maybe I should open source it right now and you may present it.
Sure. Let's we can try that.
Okay, just a moment. Okay, so I've made it public. Let me share it in the chat itself if you want.
Sure.
This is it.
Let me put that onto the YouTube chat. So we're taking a look at this,
Code could be
everyone.
quite messy, so please don't mind it.
So we have you to explain things. It's all right for now. Uh, let's head over here. So you this is the stacking approach that you had taken, correct?
Yeah, usually I see that people don't usually share this approach. Like it was used by many teams, but I guess no one shared the code for this, right?
I don't think the stacking code has been revealed. So let
Mm.
me.
Yeah, so just for the example, I took one of the out of folds of a model so that you could read in the starting part that I am simply reading the out of fold predictions in a
Mhm,
data frame and then selecting the prediction columns, and then I come up with some of the feature engineering part which you could see below.
mhm.
So if you could see, this was the OOF score before the second stage, 0.611 log loss. And after adding these features and those predict, predictions of the out of fold, then after the training, you might see there was quite a boost with that. So I might have to explain this because I named the variables quite complicated.
I'm trying to find the boost just to like show the difference. So I think that comes afterwards, no? So you jumped from 0.61 to 0.60.
Yeah, right. Almost 006 boost.
Which for as you all know by now is like a nice boost for Kaggle, although it's just second digit. So
So
where
some of the features which I used was like just like them. I simply took the discourse type length, like sorry, discourse text length, like how large the text is. So those features, then I grouped them by the SAID and took the mean, standard deviation, and the minimum of all those features according to by grouping them upon SAID. Then I took those features along with discourse type as well. Like for each SAID and discourse type, I grouped them again. Then I again took mean and all those additional features, aggregated features from them. Then I grouped them with SID again and ranked them. So basically, I tried to rank etiquette or any predictive columns. So that again come up with a good amount of push. So I kept on doing some feature engineering and not started noticing like which one is doing well.
Mhm.
So surprisingly
Thanks.
did pretty well on leaderboard also. So I was expecting that it might overfit the cross validation score because I'm doing too much of aggregation and feature engineering in second stage, but it worked pretty well.
That makes sense. Um, Again, it's
Yeah,
like
so I
it
used to
as
try two models, LGB and XGB. So this might be the XGB model, XG boost.
yeah.
Yeah,
I was
go
going to
ahead.
say again, as you
Hmm.
explain it, it sounds so simple, but again, like it gives such a nice boost, like the small techniques.
I don't think it's complicated, but it's quite new compared to what, like, only recently people are more into the second stage or third stage. Like, it was quite famous for tabular competitions earlier, but nowadays, like, even in NLP competitions or computer vision competitions, where we are already using transformer based models, and yet we have to rely on second stage. So, that is quite interesting.
Okay, thanks for explaining this. Now coming back to Tushant's write-up, I think this was the one. Yes, uh, not Tushant's team's write-up. Um, they shared things that had most impact, things they did for diversity. You can read through that. Uh, and then they mention how to make training stable. So this is one thing that I have mentioned twice already, but parameter selection for NLP model, as I've learned, is like very key. um, Next they say cosine learning rate scheduler, which is also something that Nischay taught me in the AI for code competition. So he was always saying use this, and I was trying other approaches, but he was nudging us towards cosine learning rate schedulers.
The funny
um,
thing is, I didn't use cosine learning rate in this competition. I used polynomial scheduler.
so now you know what you missed.
Sorry about that. Okay.
uh, you're just apologizing to yourself. You'll get the cold eventually, we hope. Uh,
Please cut this part.
we like embarrassing ourselves live on chai time. That's why I've shifted to, to live streams, not because it makes editing any easier. Um, I think other things are quite straightforward. This is something that FastAI popularized, but it's really common now. Layer-wise learning rate decay, and this is really strange to me. So full precision training, they say, was helpful, which I find counterintuitive because I would use half precision. Um, I think that covers it pretty well. I would just say one thing here, that their team name was Darjeeling Tea, and I was really happy with that. So I'll probably also also leave a comment here. Um, okay, I just wanted to do that live for some reason. Uh, I think we have time to cover one more solution, so we can just cover the fourth place one as a last read through. Maybe I can do a follow up one if there's enough interest. If you're watching this later, or if you're watching this live, please just drop a comment in the chat, or comment that if you want to watch the remaining of the solutions. But usually the top 5 or 6 cover almost everything that's there. So they say the short version is their solution is based on Deberta V3, mass language modeling, pseudo labeling, and stacking with LGB. All the things we've covered already. So as you can see, in 3 solutions, we've pretty much covered everything already. And they found a combination of number of NLP improvements added to a solid score. So I think they're also referring to model diversity. They say the core of their solution was to combine in order all IDs and then start and finish them with type IDs and a special token. So seedless position was used at start and end of the discourse, like so. And they've also shared an example, which, if you remember the first position we had just read a while ago, this is quite similar to that, I would say. Vadim says he wants us to read the 88th position solution. So I'll try to get there as well. Um, Auxiliary labels such as ranking ineffective to adequate to effective and essay topic cluster were also used. They also used the essay text, which was not in annotated discourses to the end and sometimes positioned in order between discourses. They say replacing line breaks with special tokens and cleaning text found to increase diversity significantly. So they were removing line breaks with special tokens and also doing more pre-processing that they don't share here. Um, I've read through this, so I don't think there's anything special to highlight here. It's quite straightforward, so you can read through it as well.
One thing they did out of the box, I would say, was the auxiliary target of rank and using RMSE loss as auxiliary loss. So that looks quite different, and I don't know how it worked well for them, because they are basically ranking the target variable. So that's something new.
Thanks for pointing that out. Um, I think I'll just cover this quickly, just to make sure I don't miss anything. So first model, they had 3 different models, and their first one used non-discourse essay text, moved back to the input. So I assume essays that didn't have any labels, they moved it to the back of the input and cleaned with line breaks added. Then Nishcha already pointed this out, along with a linear head extracting the first token of each discourse in the input with categorical cross entropy loss. Second type was non-discourse essay text. So I assume essays without labels between discourses, no cleaning this time or no line breaks added. Again, similar loss added, and 0.2 weight is given to auxiliary loss. Linear head, this time extracting last token of each discourse and input with cross entropy loss, same as earlier. Sorry, this time they're using the last token instead of the first token. So that's the difference. Followed by a third type, non-discourse or non-labeled examples between discourses, no cleaning or no line breaks. This was actually 2 models, one with the RNN head applied to mean pooling, and one with an attention head to the same input. They say it is important to remove Deberta hidden layer dropout on all models, and it was quite helpful to pre-train weights of earlier feedback competition essays for 20 epochs. They say all models were trained for 2 or 3 epochs with the following learning rates. Next, they talk about using meta pseudo labels from the earlier competition, and in-fold predictions from all models were used to create an averaged in-fold prediction, which gives them a leak-free pseudo label. And then they retrain these on the current model. So the previous model is used as a form of pre-training for the second level stacking, and then they finally fine-tune it towards the last model. They stack this by averaging all of the predictions in a light GPM model and training it at a discourse level along with meta features. And the features they use are word count, sentence count, in essay topic, lead and lag features without any post processing. Any other thing you want to mention here?
No.
Just to, we're out of time, but just to honor my promise to Vadim, I'll jump to 88. I know I skipped a solution from earlier, but I'll quickly cover this. So Vadim is our friend from Ukraine. He's one of the youngest discussion GMs and on the way to paint rest of his profile golden. But let's see what their team have come up with. Um, so I'm just reading ahead because this one I didn't read before the live stream. Um, they say they used grouping by SAID and stratify by discourse effectiveness. So this was their CV approach. They used for one epoch, trained for one epoch longer, and they used pre-trained weights from the earlier feedback competition. They had 3 classification models with the following score, and they replaced this with one classification model with token classification. Sorry, I misread this. So they had 3 models and they replaced one with token classification and added one more with a different approach. Vadim, can you clarify this, please?
Maybe they are trying to say like they used three models, but in the beginning they used all three of them sequential. Then they had one token wise classification model, then another token wise that gave them additional boost.
Yeah, maybe I'm just too dumb to understand in one read. He says yes. Okay. Thanks for clarifying. Um, Even for them, pseudo labeling didn't work, and I think Tushant's team also mentioned that they missed this approach.
Mhm.
I think that covers it. They've open sourced the solution as well, so you all can read it. They say with pre-trained weights from same feedback competition and not the older one. Thanks for clarifying that. Okay. Congrats on the 88 position finish. And I know we, we didn't get through a lot of solutions, but we did cover a lot of things. So again, if it's of interest to everyone, please let me know. Nishtay probably won't waste his time on another live stream, but I'll cover the remaining solutions, or we'll find another competition to go through. So thanks again for joining me. Thanks again very much, Nishtay, for joining me on the live stream. I'll drop
Thanks for inviting.
Nishtay's I'll drop Nishtay's Kaggle profile again. You can find his different profiles there, or you can catch him at one of H2O's live stream as well, since he's a part of the team now. Um, we'll meet again, everyone, next week to go through more top solutions, either of this competition or another one, again at 8 a.m. Pacific. And thanks very much for your time again, everyone, and thanks, Nishay.
Sure. Bye, guys.